LLM does not have the capability to fetch live data. It also does not have any means to be able to perform any action. These two weaknesses, it uses something called as a tool. It's a very fundamental architecture. There's a map of tool name against function name. This fundamental architecture is the building block of agents, so it's very important for you to understand it very well. In this video, we'll talk about the tool use and function calling pattern. An LLM, you might know, that takes query from the user and responds back to the user. So it takes content, it could be text, images, videos, and it responds with the content. Now this LLM does not have the capability to fetch live data because it's trained on snapshot of data. So it can only respond from its training. It does not have access to real-time or live data. It also does not have any means to be able to perform any actions because it does not have functions or inbuilt functions. These are the two weaknesses of the LLM: inability to take actions and real-time data. For these two weaknesses, it uses something called as a tool. What is a tool? So tool is essentially a function which takes some inputs and outputs the response based on what it's doing. So it's a function. Now, some of the functions that the LLM might need could be responding to the user with the help of some external API. For example, it could be fetch the weather today or fetch the date today, or even an action which could be, for example, write in my calendar or write an email and send it to someone. So these are some of the actions or some of the real-time data that this tool can respond and fetch. How does an LLM use this tool is based in a fundamental pattern we'll discuss in this video. We have a main function that essentially writes the entire code that takes help from the tools and the language models to be able to answer to the user. Now this main function is our main application code. Let's understand it with the help of the same example. What's the weather in Tokyo today? To be able to answer this question, the LLM needs access to the weather and the date today. Weather today and the date today. So we have a certain set of tools available to us and that are written in a separate file known as a tool description file, which has all the tools and their descriptions. So these files are essentially JSON files. So the tool definition files look like this. So it has tool name, key value pairs in a JSON, so tool name and the name of the tool. Then the description, it could have the parameters this function corresponding to this tool takes in, and the parameters. So in our case, let's say we need a weather tool to be able to answer to the user what's the weather in Tokyo today. So the tool name could be get weather, description could be provides weather in a particular city on a particular date, and the parameters would be date and city. So we have all these tools defined in advance and available to us at our disposal within the main function. In the main function, we send the query to the LLM and we send the tool definitions as well to the LLM. The LLM does not solve our problem, does not answer to the user, but the LLM finds the right tool corresponding to the query as well as parse the exact parameters this particular tool needs to be able to answer this query. So in our case of find the weather in Tokyo today, the LLM has access to all the tool definitions, different tools that are available to us, and the query that I just mentioned. It finds the right tool based on the tool description. So in our case, it finds the tool known as get weather and sees what the parameters it needs, date and city. So parses these two parameters from the query and returns these in a JSON file. So the tool name, parameters, city is in our case Tokyo, key value pairs since it's a JSON file, and the date today. So you saw that this LLM does not solve user problem, but this LLM essentially answers us with the right tool. Because in this main application code, in this fundamental architecture we are discussing, the LLM is not completely autonomous. It's not solving the problem. It's just returning the right tool and the parameters that this tool will take. In the next line, I will have some guardrails around right tool, right parameters, and then in the main function itself, I will call this exact tool, which I mentioned is essentially a function. So there's a map of tool name against function name. I'll find that function. I'll call that function with the help of the parameters that were output by the LLM. Now, once I have called this tool will answer me the weather today in Tokyo. Now, I'll take that and send it back to the LLM to formulate the response to the user using the output of the tools. So what happened in this code is I took the help of LLM, I took the help of external tools to be able to answer user query. I did not provide the LLM the entire ability. Why did I do that? It's a very fundamental architecture, and why am I coding a lot of these things is because I need to use the guardrails. Briefly, guardrails are essentially very important for safety of the code. If, let's say, the LLM uses some tool that deletes the database or some tools that it should not have used, because LLM is probabilistic, it's not 100% reliable. So I need to have some guardrails around what it's outputting and whether it's the correct output that I could send to the user to check several things. In the absence of the LLM, it would have been very difficult to select the right tool and very unreliable to select the right tool just by parsing, let's say using regex or some traditional models. It would not have been great to use them to parse exactly what tools I need and what exactly would be the answer to the user and respond in the right way. So I am using LLMs in the right way that I need to. You might think that, okay, this main code, I have talked about this kind of code in which I'm calling LLM in a loop. So where have we heard of it? This main code is nothing but an orchestrator we talked about in a couple of videos back. How is this orchestrator different from an agent? Very important. In the orchestrator, we saw that there are several guardrails that I have put. I have coded a lot of the things myself. So there is some human intervention or the architect intervention here. An agent is almost completely autonomous. So there's no clear line between or demarcation between an agent and orchestrator, but generally orchestrators have more guardrails, more human control, but agents are more autonomous systems. So let's basically summarize the mental model of what we discussed today. So there are three main components to this fundamental architecture of an orchestrator. Those are language model, could be large or small language model. The second biggest component is tools, which are essentially the functions that are either helping the LLM make actions, perform actions, or helping the LLM fetch live data. Then we have the third component, the biggest, the most important component is the main function, main application code, or the orchestrator, which puts everything together in loops exactly the way we discussed a couple of videos back, in which it replans everything after every single step, performs the whole loop, and then replans the next step again and solves the problem until satisfied with the solution.